this video, I'm going to explain cells in parallel. When we connect cells in parallel, all the positive terminals of the cells are connected to a point, and all the negative terminals are connected to a point. Then these points will be the positive and negative terminals of the battery. This is a positive terminal of the battery and this is a negative terminal of the battery. Across that, external resistance is connected. Now let us see the effective value of the EMF and the current. Then effective value of the EMF is the potential difference between the points A and B. That is equal to psi. The EMF of each cell is psi, and potential difference across this point A and B is also psi. So total EMF is psi. In series connection it is N times E, but here it is psi. Now effective value of the internal resistance, each cell internal resistance is R, small r. Since the cells are connected in parallel, resistance are also in parallel, internal resistance are also in parallel. So when resistance are connected in parallel, effective value of the resistance is given by this expression. 1 by R, effective value of the resistance, is equal to 1 by R plus 1 by R plus N times 1 by R. Then 1 by R is equal to N by R. This is the effective value of the resistance, Req. 1 by Req is equal to N by R. Now take the reciprocal. So effective value of the resistance or equivalent value of the internal resistance is equal to R by N, reciprocal of this, R by N. Then total resistance is capital resistance plus equivalent internal resistance, that is R by N. Then current is given by Ohm's law, EMF divided by the total resistance. Then this can be written like this, NR plus R and this N. So this total current is N psi divided by N capital R plus small r. Now there are two cases. Case A, when internal resistance is very much greater than external resistance. Here R is very much greater than the external resistance. So then this can be neglected. This R is very much greater, so this can be neglected. So N psi by R. The current is N psi by R. Then when R is very much less, it is negligible. Then psi by R. Psi by R is I1. That is current due to single cell. Current due to single cell is psi by R when capital R is negligible. So the current is N times the current due to single cell. Case B, in this case capital R is very much greater than small r. External resistance is very much greater. Now this small r can be neglected, then this N will get cancelled. So total current I is equal to psi by capital R. So the psi by capital R is the current due to a single cell. From this it's clear, when we connect cells in parallel, it's advantageous when internal resistance is very much greater than R, capital R. That means external resistance is very much lesser than the internal resistance. Current is N times I1, so there is an advantage. Then when external resistance is very much greater than small r, that is external resistance is very much greater than smaller, current is psi by R. So current that is equal to the current due to a single cell. In this circuit, 4 cells are connected in parallel. So N is 4, number of cells 4, 1, 2, 3, 4 cells are there, and EMF of each cell is 5 volt and internal resistance is 0.5 ohm. Here an external resistance of 10 ohm is connected. Let us find the current, main current. I. So equivalent EMF is 5 volt. When we are connecting the cells in parallel, potential drop difference between the point A and B is the equivalent EMF, that is 5 volt. Each cell 5 volt, but equivalent EMF is also 5 volt. Then equivalent internal resistance. So internal resistance of each cell is 0.5. So this cells are connected in parallel. So internal resistance also connected in parallel. So equivalent internal resistance is R by N. 0.5 divided by 4. Internal resistance of each cell is 0.5. 4 cells are there. So equivalent internal resistance is 0.125 ohm. Then current is given by this relation, EMF psi divided by total resistance. External resistance is capital R. Then the internal resistance of this 4 cell is R by N is equal to psi. Psi is 5 volt. Then external resistance is 10. Then R by N is 0.125 ohm. Then 10 plus 0.125 is 10.125. This is approximately 0.5. This can be taken approximately 5 by 10. This is 0.125. So 5 by 10. Approximately it is 5 divided by 10.125 is approximately 0.5 ampere. So the current is 0.5 ampere. Then potential difference across each cell is same as the potential difference across this external resistance. So current is 0.5, then resistance is 10. So V is equal to IR, I is equal to 0.5 into 10, that is 5 volt. So the potential difference across each cell is 5 volt. Then current from each cell is 0.5 divided by 4. 4 cells are there. So here 0.5. 0.5 divided by 4. So current through each cell is 0.125 ampere. Thank you for watching.